So today we're going to learn about adding and subtracting positive and negative fractions. So we know from basic fractions that all you have to do when you're adding fractions is make sure you have a common denominator. And once you have a common denominator, you just add the two numerators together and you keep that same denominator. The same thing happens with subtraction, only now we are changing subtraction to addition. So we would change that subtraction to addition, and then the whole entire fraction's value will become the opposite of what it started as. So in this example, B over C was a positive value. Now that entire fraction is a negative value. So once again, we will add the numerators once we have a common denominator. So we keep the denominator and we add the two numerators. And it doesn't matter if they're positive or negative, we still just add those together. Okay, so if we were to look at an example like 6/9 plus negative 11/9, we would just add our numerators. 6 plus negative 11 and keep our common denominator, 9. So that would give us negative 5/9. So let's look at this further. So we're going to use the integers in our fraction problems to determine the operation, like we always do. So for example, if I have 6 plus negative 12, the fact that I have a positive and a negative and I'm adding those different signs means I'm actually going to subtract the numbers. We don't change anything. We just know that 6 of these positives are going to cancel with 6 of those numbers. So in our head, what we do is we subtract 12 minus 6 to get 6. And the next thing we do is we determine the sign of the answer based on the integers. Well, here we have more negatives than we do positives. Therefore, our answer is actually going to be a negative 6. So our final answer is negative 6. So we understand that when it comes to basic integers like 6 plus negative 12. Now we're going to apply the same idea to mixed numbers and fractions. So here we have negative 5 1/4 minus 2 1/3. The first thing we need to do is change this to addition so we can tell the sign of each of our mixed numbers. So this means that 5 1/4, that entire value is negative. And 2 1/3, that entire value is negative. So if we were to look up here, it would say use the integers to determine the operation. So we're adding the same sign. So do we add those values or subtract them? We would add them, because whenever you add the same sign, you're just getting more of that sign. Then we're going to determine the sign of the answer. Well, if we have negatives plus negatives, that just gives us more negatives. So our answer is going to be negative. Now, one thing that I want you to keep in mind here is you can estimate what's going to happen by looking at your mixed numbers as whole numbers or integers. So I can think about this as negative 5 plus negative 2. And the process I use for adding negative 5 and negative 2 is the same process that I'm going to use when I add those mixed numbers. So I add them together because they're same signs, and I get a negative because I'm adding negatives and more negatives get a whole bunch of negatives. So now I do the same process, only I have to get common denominators and apply my fraction rules. So why don't you take a minute and see if you can figure out what that equals. Pause the video and check. Once I get common denominators and add, I end up with negative 7 and 7/12. Notice that answer is fairly similar to when I dropped the fractions and just added the whole number. So that's a way to check and make sure that you're using the right process. Let's look at another example. All right, so what should we do first here? Change it to addition, right? When we do that, 7 and 4 over 21 is going to become negative. So let's think about what we would do, first of all, if these were just integers instead of rational numbers. So 4 plus negative 7, would you add or subtract those? So in your head, you would say 7 minus 4 is 3. And then would you have more negatives or positives? More negatives, so your answer is negative. Okay, so this helps us to think about this, that we're going to use that same process with fractions, only we have to get common denominators. In this problem, we're going to use prime factorization because the denominators are fairly big and they're going to have common factors. So can you think of something that would go into 15 and into 21? 3, right? So since they have common factors, we're going to use our prime factorization method. So let's look at that. So for 15, we're going to break this down to 3 times 5. For 21, we're going to break this down to 3 times 7. So now we're going to multiply each of the fractions by whatever is missing from the other fraction. So first, let's circle what they have in common. Both of these fractions have a 3 in common. So we don't need to worry about that 3. They both have it. But the 2 has a 5 or the 2/15 has a 5 and the 4/21 does not have a 5. So I'm going to multiply this by 5 over 5 so that it now has a 5. And then if you look at 7 and 21, 21 has a factor of 7, but 15 does not. So we're going to have to multiply the 15 by 7. So now you can see that they both have the same factors in the denominator, and this gives us a common denominator. They both have a 3, a 5, and a 7. Now we're going to multiply to get our common denominators. And when we do, we get 4 and 14 over 105 and negative 7 and 20 over 105. So we now have our common denominators. Now I see an issue here. Does anybody see it? You cannot, 4 is smaller than 7. So we need to put these numbers the other way around. You can't take 4 from 7. So I'm actually going to change this around to negative 7 and 20 over 105 plus 4 and 14 over 105. Okay, now I have something I can work with. So remember, you always have to have your larger value. That whole mixed number is larger than this whole mixed number. Okay, 7 is larger than 4. So don't worry about the signs. You just have to have the big number on top, just like with decimals. All right, so now I'm going to subtract. 20 minus 14 is 6 over 105, and 7 minus 4 is 3. Do we have more positives or negatives? We have more negatives. So notice we had estimated the answer to be negative 3. And what do we get? Negative 3 and 6 over 105. Okay, now I need to see if I can simplify. So let's think about our divisibility rules. What's 1 plus 0 plus 5? Isn't that 6? That tells us that 3 will divide into 105, and we know it'll go into 6. So when we figure it out, we get 35. So we need to simplify to get our final answer of negative 3 and 2 over 35 because we divided by the greatest common factor of 3 in our fractional part of our mixed number to simplify. And this is your answer. Okay, let's move on. So I want you to try this one with the prime factorization and come back and listen to the explanation if you get stuck. So first we're going to change it to addition. We need to think about which one's bigger. So let's go ahead and do that. So negative 8 and 5/18. If you don't worry about the negative, then the absolute value, that's a much larger amount than 2 and 3/20. So we really need that number first. The 8 needs to come first. And since we changed this to addition, we can move that order around. So changing to addition is really important. All right, so we end up with 2 mixed numbers that have different signs. Let's think about how we would approach negative 8 plus 2. What would that equal? Negative 6, right? So we're going to do the same thing we did here. What we did in our head was we subtracted, and then we kept the negative because we had more negatives. So we're going to do the same thing. We're going to subtract and keep the negative. So negative 8 and 5/18 plus 2 and 3/20. So even though there's addition, we're adding different signs, which means we have to subtract. So the first thing we need to do is get a common denominator. And I know that 20 and 18 have a common factor of 2. So I know I'm going to use my prime factorization method. So I'm going to multiply 2 times 3 out here to show the prime factors that go into 18. and 2 times 2 times 5 to show the prime factors that go into 20. What they have in common is 1, 2. Okay, so what we need to do is take the ones they don't have in common and multiply the other fraction by those. So we're going to multiply 5/18 by 10 from right here. 2 times 5 is 10. Okay, so we're going to multiply times 2 times 5, which is the same thing as times 10. And then we're going to take the 3 times 3 from right here, and we're going to multiply that by the denominator times 3 and by the numerator, which is 3 times 3 is 9. So just multiply times 9. So now we can look at our denominators and make sure we have all the same numbers to get our common denominator. We should have 2 2s, 2 3s, and a 5. 2 2s, 2 3s, and a 5. All right, so we should be in good shape. Now I'm going to multiply 5 times 10 to get 50. And I'm going to multiply 18 times 10 to get 180. 2 times 5 is what we add here, or what we're multiplying in it by 18, and that's 10. And then 2 and 3/20ths, 3 times 9 is going to be 27. 3 times 9 is 27. And then for the denominator, 20 times 9 is also 180. And of course, we should be getting the same denominators, but it's good to multiply them out to double check yourself. We're going to add these together. Since they're different signs, we subtract. So 50 minus 27 is going to be 23. We keep our common denominator. 8 minus 2 is 6, and we have more negatives than positives. Again, notice our answer is very similar as what we ended up with when we were just looking at the whole numbers and not the fractional parts. Let's keep going. All right, try this one. So for this one, you will end up with negative 6 and 5/14 plus 9 and 2 over 21. We're going to put our 9 and 2 over 21 first. So we end up with 9 and 2 over 21 plus negative 6 and 5/14. Next, we're going to look at, see if we have any common factors. Well, 14 is 2 times 7, and 21 is 3 times 7. So we have a common factor of 7. So we already have that in common. So we just need to take the factors that we don't have in common and multiply the other fraction by it. So I'm going to take the 2, the factor 2, and the number 14. I'm going to multiply that in the numerator and denominator to get an equivalent fraction with a common denominator. Then I'm going to take the 3 and the 21 and multiply that by the 5 and the 14 to get a common denominator. I'm going to double check and make sure that both of my denominators have the same prime numbers. So I have a 3, a 7, and a 2. For the first fractions denominator, I have a 2, a 7, and a 3. So same thing for the second one. So I'm in good shape. Now I'm going to get those common denominators. So I get 9 and 4 over 42 plus negative 6 and 15 over 42 when I multiply those out. Now just real quick note, I'm going to add 9 plus negative 6 to make sure I'm on the right track, and I get positive 3. So that reminds me I'm actually subtracting these two numbers, and I'm keeping the positive sign. So now when I go to subtract, I notice that I have a 15 being subtracted from the 4, so we're going to have to regroup that top mixed number. So we're going to take 1 away from the 9, so that becomes an 8. We're going to add that 1 whole as 42 over 42, which gives us 46 over 42. So now I can subtract. So 8 minus 6 is 2, and 46 minus 15 is 31. And we end up with 2 and 31 over 42. And it is positive because we had more positives than negatives. Let's keep going. All right, so here we have multiple fractions. So what I like to do is I like to add all of the same signs together first to cut down on subtracting. So we're going to go ahead and make this all addition. And then for me, I'm going to add -2 1/3 plus -5, then plus 2/3 in that order. So this should be pretty easy. So I want you to keep something in mind. If you do not have a fraction with one of your numbers and you're adding it to a mixed number, just put a 0 in as your numerator and use the common denominator to help you keep up with your fractions. So since I'm not subtracting, it doesn't really matter which goes on top and which goes on the bottom, but I'll go ahead and put my bigger number on top. Remember, it's a smaller value because it's negative, but we want the bigger number. All right, so that's just going to give us -7 1/3 because we're adding. And they're the same signs. So now I'm going to take that -7 1/3 and add positive 2/3 to it. Hey, look at that. We have common denominators. Yay! So I'm going to regroup. I'm going to take 1 away from the 7 and make it a 6. And then I'm going to add 1 whole to my fraction as 3/3, which gives me 4/3. So here we're subtracting. So 4/3 minus 2/3 is 2/3. And then 6 minus, again, there's nothing here for the whole number, so just imagine a 0 there. So you get 6 2/3, and we have more negatives than positives, so the answer is negative. Let's go down to the next one. I'm going to go ahead and change subtraction to addition right here. Then I'm going to add my 2 negatives together first, because once you have all addition, you can add in whatever order you want. So I'm going to add -6 1/6 plus -3 3/20. 6 and 20 both have a common factor of 2. So I'm going to try prime factorization here. So I have 2 times 3 for 6 and 2 times 2 times 5 for 20. Or 4 times 5 is 20. They have a common factor of 2. So I need to take this 3 here and multiply it by the other fraction because it doesn't have a 3. And then I need to take this 2 times 5, in other words 10, and I need to multiply that by the other fraction. Okay. This is times 2 times 5, which is the same as 10. All right. So now what I'm going to do again is double check that I have common denominators now by having the same factors. I have 2 2s, a 3, and a 5, 2 2s, a 3, and a 5. Good. I'm in good shape. So now I'm going to get my equivalent fractions. So this is going to be -6 and 10 over 60 plus -3 and 9 over 60. They're both negative, and when you add negatives up, you get more negatives. So this is going to be -9 and 19 over 60. All right, now we still have the positive 5 and 5/8 to deal with. So we need to, since 9 is bigger than 5, I'll put that as my first number. So -9 and 19/60 plus 5 and 5/8. Again, we have some common factors between 60 and 8. So the first common factor I can think of is 4. So this is going to be 2 times 2, that's 4, is 4 times 15. So 3 times 5, 15 times 4 is 60. And then 8 is 2 times 2 times 2. So they actually have 2 numbers in common, 2 times 2, or 4. All right, so the numerator or the first number has 3 times 5 in the denominator, and the other number does not have a 3 times 5, so we need to multiply the denominator by 3 times 5, or 15, which means we're multiplying the numerator times 15. Okay, and then for the number on the top, we're missing this third 2 that the 8 has as a factor. So we're going to need to multiply another 2 by the denominator and the numerator. Oh, we're getting some big fractions, right? So here, we're going to end up with -9 and 38 over 120 plus 5 and 75 over 120. Now, we're going to have to subtract because these are different signs, and we can't take 75 from 38. So we're going to have to regroup. This will become 8, and then we're going to add that one whole that we took away to the fraction 38 over 120. And that'll give us 158 over 120. Okay, so now we can subtract. So 158 minus 75, that's 83 over 120. 8 minus 5 is 3, so you get negative 3 and 83 over 120. That's our final answer. Let's go back and very quickly estimate the answer here and just see if we're on the right track. So here we would have, if we looked at this as just integers, no fractions, we'd have 5 plus negative 3 plus negative 6. So that would equal 2 plus negative 6, which is negative 4. And we came very close to negative 4 for our answer, for our final answer. So we can feel confident we're on the right track. Okay, now comes the fun part, fractions with variables. So with fractions with variables, you follow the same exact rules that we started out with in this lesson. You always get a common denominator if you don't have one, and then once you have one, you add your numerators. Here we already have a common denominator of 6. So we're going to keep our common denominator of 6, and we're going to add our numerators, which means we'll add b plus 5. And we can't do anything else because you can't add a variable to a number unless you know what that variable is equal to, and we don't. So this is the final answer. Okay, so here we're going to change this to plus and negative. And do we have common denominators? Yes. So we can go ahead and do this problem. Since we have common denominators, we keep that denominator. Now we can add the numerators. And you don't have to show this step, but that's what you're doing in your head. So 5 plus negative 3 is 2. You get 2 over g as your final answer. Let's look at number 3. So one thing with variables and fractions is you cannot work with mixed numbers. So this is kind of the opposite of what we've been talking about. So this does not equal 3b and a half. Okay, that's not the way you approach it. So instead, we have to think of this as improper fractions. So we're going to think about 3b as 3b over 1. And then we're going to add 1/2 to that. So what's the first thing you do with fractions? To add them. You get a common denominator, right? 1 is never going to be your common denominator. So in this case, 2 will be our common denominator, since I can get 1 to multiply by 2 to equal 2. So I'm going to multiply the numerator by 2 and the denominator by 2. That will give us a common denominator. So you do need to understand that 2 times 3b is the same thing as 2 times 3 times b, which is 6b. Okay, and that's your final answer. Another way to think about it is 2 groups of 3 groups of b, which is 6 groups of b. So 2 times 3b is 6b. 2 times 1 is 2. Then you're going to add 1/2 to that. So now we have common denominators, so we're in good shape. And we know that once we get common denominators, all we have to do is keep that common denominator and add our numerators, 6b plus 1. Now, we can't do any more than that because we can't add 6b to 1 since there's a b involved, a variable involved with 6b, and 1 is just a constant. So that's our final answer. Let's move on. Let's look at this example. This is very similar. So again, this is not going to be 2x over 3x. That is not right, okay? You have to actually work with improper fractions if you're working with variables. So what we're going to do is take 2x over 3, add it to the x by putting x over 1, because any whole number can be written as that number over 1, even if that number is a variable we don't know. All right, so now we have to look at our 2 denominators and see what we can do to get a common denominator. Well, between 3 and 1, we can get a common denominator of 3. So I'm going to multiply x over 1 by 3 over 3 so that we can get a common denominator. So I'm going to rewrite this problem as 2x over 3 plus 3 times x, and then our numerator is just 3x. It's 3 groups of x. So we write that as 3x, and then 3 times 1 is just 3. So do we have common denominators now? Yay, we do! Now that we have common denominators, we keep following the pattern of working with adding fractions, which is add your numerators, keep your common denominator. Now, can we add 2x and 3x? Why, yes, we can, because 2 groups of x plus 3 groups of x is 5 groups of x. So your answer is 5x over 3. Now, you cannot simplify this. I know that 5 is bigger than 3, but you have to leave it improper like that. You have to, because you don't know what x is. So 5x over 3 is your answer. Let's move on. So here we have 4 over x, plus negative 3. Okay, so that negative 3 can be written over the number 1 since it's a whole or an integer. So, and any integer can be written over 1. So we have 4 over x plus negative 3 over 1. So getting a common denominator, what do you think between 1 and x? Which one do you think we'd use? If you think x, you're right, because you can't change the x to a 1, but you can change the 1 to an x by multiplying it by x. So we're going to multiply the 1 times x in order to get a common denominator of x. In doing so, we also have to multiply the numerator by x. So we're going to end up with 4 over x plus negative 3x over x. Now, do we have common denominators? Yay, we do. So now we can add our numerators. So we're going to add and get 4 plus negative 3x, and we keep our common denominator of x. Can we add a 4 and a negative 3x? No, the 4 doesn't have an x. However, I am going to put this in standard form. So if you'll think back to the last unit, we talked about standard form. The standard form is where you're adding like terms, which is what we just did. And when you add like terms, you always put the term with the variable first and the constant last. And that is the end.